Okay. Okay, recording is on. All right. So let's talk some math, ladies and gents. So here's our warm up. So, again, remember, we are representing data. A police radar unit measured the speed of 25 cars on Elm Street. The resulting speeds were, and here is the list of 25. Your task is to construct a histogram and a box plot using the speeds. So that means you are creating a histogram and a box plot of the same data. So, according to my clock, I have 10:45, 46 now. So at 5 minutes to 11, we're going to talk about it, ladies and gentlemen. Let's have some conversation. I hope that you all have some notes that you can refer to, because I have been telling you, and I tell you in every invite, bring pencil and paper. Treat this just like we were in the classroom. And these are some things that I say, take note. You should have wrote them down or took a screenshot, since we are virtual. Because again, in times like this, that's what you'll be referring to. So work it out. And I am here for any questions, comments, concerns. I will try to, I'll leave it up for a minute so you can get the data itself. Hello. We are working on the warm up. The warm up is there. Again, we are using the speeds that were clocked by the police radar unit on Elm Street. There are 25 of them. And again, you are constructing a histogram and a box plot. We will, good morning. We will be discussing this in just a moment. Let me see. Let me see. Hi, Nakaya. Hi, Shanice. So that was Nakaya. And Shanice. Now, where is Janae? Let me send her a text and tell her, come on here, girl. And again, ladies and gentlemen, this is practice. Math is a verb. You got to do it in order to get better at it. Good morning. How do? We are working on this warm up that you see on the screen. We are constructing a histogram and a box plot of the same data.
You want me? You gotta put the numbers in order.
All right, well, wait a minute.
All right.
Give them a minute. We got 3 minutes. Then we're going to talk about it.
All right.
Oh, thank you, boo. All right, I got you, Nay. Oh, wow, that's corny. All right, we're going to take about 1 more minute and then let's have some conversation, ladies and gentlemen. That means I'm going to talk to you, you're going to talk to me, and we're going to work through this. All right, peeps, let's do it. All right. Now, histograms and box plots. So it is always easiest. First, put the data in order. So in your data set, you should have had, you should have had 20, you should have had 4 23s, 3 24s, 4 25s, 1 26, 2 27s, 3 28s, 2 29s, and 6 30s. And that would have made up the 25 numbers in, or the 25, speeds in the data set. So now remember, ladies and gents, when you construct a histogram, you organize the data in bins. And we use a frequency table to do that, okay? So remember, when you create a histogram, your histogram is your own. So they may not look the same because it will depend on the width of your bins. So somebody may have constructed a bin that goes only from 23 to 24 or 23 to 25. And then their bin goes 25 to 27, again, or somebody else may have gone 23 to 28. So now their bins are going to be 5 units apart. Okay? So just because your histogram may not look like the histogram that I present here, do not think that yours is incorrect. Because again, it will depend on the width of your bins. So for me, my bins were 3 units long. So I went from 23 to 26, then from 26 to 29, and then 29 to 32. Remember, a histogram is continuous data. Therefore, the end of one bin is the beginning of the next bin, okay? And the end point, the upper end point, gets counted in the next bin. So when we look at the data, and again, my bins were 3 units apart. So in my bin from 23 to 26, I have 11. And you will see those 11 terms here in this box. And you see in this first bin, you do not see 26 because 26 gets counted when it is the beginning. Okay? It does not get counted when it is the end, the end of the bin. It gets counted when it is the beginning. So in my first bin, 23 to 26, I have 11, and here are the 11. In my bin from 26 to 29, here are my 6. And in my bin from 29 to 32, here are my 8. And again, even though our data only went to 30, we still have to keep the same width of the bin, okay? And from that this set of data and that frequency table, this is what my histogram looked like. And again, I will re-emphasize, the number of bars in your histogram will depend on the width of your bins. So if you went 23 to 25, and then 25 to 27, 27 to 29, 29 to 31, then you would have 4. Okay? So again, depending on your width will depend on your bars. So this is, again, just one presentation. If yours does not look like this, however, you have your bins and the contents of them listed correctly, that is the key to a histogram. And anybody who was not daring enough to try, you can do a sketch of what you see or take a screenshot. We ready to move to the box plot?
Yeah.
Okay. Bam. All right. Bam. There's our data. So somebody.
It ain't showing.
You don't see it?
Oh, there it go.
Oh. Okay, so now. Somebody tell me. What's your minimum?
23.
Quay,
27.
hold your thought. What's the maximum? Somebody.
30.
Thank you. What's the middle? The median, your Q2. What
26.
divides who? Oh, yeah. All right, so now, ladies and gentlemen, there are 25 terms in the data set. So that means because it is an odd number, 27 does sit physically in the middle. So now, what 27 has done is split the data in half. You now have 12 terms on the left side and 12 terms on the right side. So now we are finding our Q1. What is the middle or the median, excuse me? What's the median of this lower end of the data? Where is the middle? What sits physically in the middle? We're looking for the median. And when it's an even number of terms, how do we find the median?
24.
24. Anybody disagree with 24? Yep. So now, look at this. We have 12 terms. So when we come in, 6, 1, 2, 3, 4, 5, 6. We hit 24 coming from the left. 1, 2, 3, 4, 5, 6. We hit 24 coming from the right. So this one was easy because on both sides, it was 24. So what are we going to do now that we're looking for Q3? What is the median of the upper portion of the data? Again, we have 12 terms from 27 to 30. How are we going to find the median?
Right, it's 30.
Is it 30? Let's see. It can't, it's 12, it's 12. It can't be 30 because 1, 2, 3, 4, 5, 6. Coming from
30.
Who?
29, 30.
Right, because remember, coming from the right, we end at 30. But coming from the left, we end at 29. And what's the rule? You add them together and divide by 2. So what's going to be the Q3 or the median of the upper end?
It's 29.5.
29.5. All right, so there are your values. Okay? And again, even though the median of Q1 was 24, I still included the math just so people can see. And they don't think that it's just 24 straight up. No, it became 24 because coming from the left and coming from the right, we landed on 24. And when we added them together, 48 divided by 2 still gave us 24. And then we see the same thing happening with Q3. Remember, if the number of terms in the data is even, you must take the average of the middle 2. Okay? So we came in 6 on both sides. And that's where we landed. All right, so now the values, the 5-number summary is presented vertically because as you move higher in your study of math or you take statistics, you may see the box plot vertically versus horizontally like that. So these are our values, and understand that when a box plot is vertical versus horizontal, whereas we say left, right, we're going to understand, remember, you have to train your thinking to bottom and top. So what would be our left whisker is our bottom, and what would be our right whisker is our top. So when we look at this box plot, and we think about what we talked about in classification, we see here that the the left whisker is longer than the right whisker. So if the left whisker is longer, then what's the distribution? Left skewed, right skewed, or symmetric?
Say that again, Ms. X.
Say it again.
No, say that again, Ms. X.
Okay. I asked, if we look at this box plot, we see that what would be, or the lower whisker, which if we turned it horizontally would be our left whisker, is longer than our right whisker. And our Q2, median of the entire data set, is closer to Q3, the median of the upper half of the data. What distribution does this box plot display? Is it left skewed, right skewed, or symmetric? Because we talked about that, and I said to you, write this down. There are some characteristics that you look for in the box plot that will tell you about its distribution. Remember, We are critically examining. We are taking a critical look at analyzing what we see. Oh, that was the cheat. Anybody remember? Oh, you should take notes, good people. But we're going to address that on the next slide. So here, and just because, you know, I addressed the question, when the lower whisker, if it is in a vertical position, or the left whisker, if it was in a horizontal position, is longer than the right, off the top, it is left skewed. Okay? So here, the lower whisker is longer and the median is closer to Q2 because that's only 2.5 away, where the distance between 24 and 27 is 3 away. That too means that it is skewed left. So does your box plot look like that? And if not, turn it vertical. I mean, turn it horizontally. It is vertical, just turn it. Turn it this way. Turn it to the right. Turn it clockwise. Okay. Are we good? I can move?
Yeah.
Okay. All right, so now, ladies and gents, here is the summary. So now, if the histogram looks like this, where you have a little bit of the data on the left side and all of the data is being pushed to the right, it is left skewed. And we see that the median of the data is here, meaning half of the data falls on that side, that's the lower half. And the other half of the data falls on this side, that's the upper half. And then we mark what is the middle of the lower half and what is the middle of the upper half. Now, when we look at the box plot, we see that the tail is on the left. So we see that the left whisker is longer than the right whisker. And we see that in the box itself, the median of the data set is closer to the median of the upper end of the data. So that is what you need to write. Draw this little box plot on your paper. Put left skewed, and under it, you will write left, and in parentheses, put lower in case you get the box plot vertically. So the left or lower whisker is longer than the right, and in parentheses, put upper whisker. And under that, you are going to write Q2 is closer to Q3. And that means the middle of the data set is closer to the middle of the top of the data or the upper end of the data. Do I need to repeat those things? And again, those of you who
Yeah,
are...
one more time is it?
Okay. Those of you who are screenshotters, screenshot. So, for the box plot, you will draw that picture and you will, under that picture, you will write the left in parentheses, put lower in case the box plot is turned vertically. whisker, close the parenthesis, whisker is longer than the right, and in parentheses, put upper, close parentheses, whisker. Under that, I want you to put Q2 is closer to Q3. Under that is the explanation of what I just said. The median of the data is closer to the median of the upper end.
Got you. Good luck, Ms.
Absolutely. All right, let's talk about symmetric because we only got, we got 3 minutes. So let's talk about symmetric. If we look at the histogram of it, you'll be able to split it in half, left side look like right side. Well, the same thing with the symmetric box plot. So draw that little picture and try to make everything even. Because if the box plot it has a symmetric shape, the left whisker and the right whisker are equal or are the same length. And the median of the data is equidistant from Q1 and Q3. That just means it's in the middle. It is equidistant, equal distance. So again, for under the symmetric box plot, the whiskers, left and right, upper, lower, are the same length. Under that, Q2 is equal distance from Q1 and Q3, and that just means it's in the middle. It's equidistant from both. And then lastly, right skewed is everything opposite of left skewed. So when we look at the histogram, we will see the tail on the right and all of the data being pushed left. And Q2 again in the middle. Again, not necessarily the equal middle where left side looks like right, just meaning it split the data into 50% on one side and 50% on the other. That's all it means. So in the box plot, we will say the left, in parentheses, upper whisker is longer than the left, in parentheses, lower whisker. Under that, Q2 is closer to Q1, which means the median of the data set is closer to the median of the lower end of the data. Okay, so again, we can see here, this whisker functions just like the tail. The middle, because the data is being pushed right, the middle is moved over. Okay, the data, I'm sorry, the data is being pushed left, so the middle is being pushed left. So it will be closer to the lower end of the data than it would the upper. Okay, so now we are at our time. I would suggest some of you stop into the lab, because this should help you with that checkpoint 2. Because up top of the checkpoint, wait a minute, I'm gonna show you the checkpoint real quick. Oh no, wrong thing, sorry. All right, here's checkpoint 2, and you all should still be able to see it. So up top are the histograms. And down the bottom of that same page, you will see the box plots. So let's look at the very first one. Everybody get to the cool down, number 2. Those of you who have not done it. Those of you who have done it, thank you. And explain, do not share your answers. Okay, because you want your classmates to know how to do this after they have the discussion with you. So, is everybody who wishes to discuss this on the histogram match? That is the name of the cool down. Okay, your silence means you agree with me. So looking at E, we have 3 bars on the left. We have a histogram in the middle, and we have 3 bars on the right. Okay, we see that the 3 bars on the left happened somewhere in the 50s. We see that our box plot is between the 60s and the 70s. And then we see the 3 bars on the right in the 80s. So we are now going to look down at the bottom. We need, now here, the circles represent the outliers. And remember, outliers are those values that are not a part of the main graph or the main box plot in this instance. And they are represented by circles. So when we look at, and I'm going to make this a little smaller so we can have them both on the same screen. So when we look at E, and we look at the box plots down the bottom, we need 3 box plot 3. So when we go down here, nope, doesn't fit. We got 3 outliers, box plot, 3 outliers. That's in the running. This one out. 2 outliers out front, 4 out back. 2 outliers out back, not going to work. When we look at the others, nope. So that means your answer should be E, and these, remember, Roman numerals, that is 4, because E, histogram E, and box plot 4 are the same data. That is the match. And then you will do the same with each of the others. Again, critically analyzing, what do you see? The same way I said to you, we have some activity in the 50s. We have most of the activity between the 60s and the 70s. Then we have some activities out here in the 80s. Well, look down here. We got some activity in the 50s. We had a box plot between the 60s and the 70s. And then we have these outliers out here in the 80s. So critically examine the histograms. Take that same knowledge, look down at the box plots, and make your matches. Is that clearer to some of you? I'm going to stop the share. I'm going to also stop the record.